this lesson, we'll be talking about factors and GCF, greatest common factor. By the end of the lesson, you should be able to find the prime factorization of integers and monomials and the greatest common factor of the integers and monomials. So factors are when the quantities are being multiplied. So if we have prime numbers, it means there's only two factors, one in itself. Composite numbers have more than two factors. Our prime factorization means we break the number down into all prime numbers. So you can use the tree method, the ladder method, or the line method. Remember that if it's a negative number, you have to add -1 to the front of your list of numbers. So to put something in factored form of a monomial means that we expand it out. So we break down the number into prime numbers, and then the variables cannot have any exponents. So for example, 14x squared y cubed, 14 breaks down into prime numbers of 7 and 2, and then we have x times x and y times y times y. For 12ab, that breaks down to prime numbers of 2 times 2 times 3, and then 3a's and b. To find the greatest common factor, that means the largest factor that the two numbers have in common. When your GCF is 1, the numbers are considered to be relatively prime. So that doesn't mean that the numbers are prime, it just means the GCF, the greatest GCF is 1. So find the factors of each number and then classify as prime or composite. So 8, our factors are 1 and 8, and 2 and 4. I always kind of make that rainbow to make sure that I have them all. And so that means this is composite. 13, the only thing I can multiply to get 13 is 1 and 13. So that means it's prime. 51, I could do 1 times 51, but I can also do 3 times 17. So that's composite. Find the prime factorization of each integer. So 90 breaks down to 2 and 45. I always try to break it down using prime numbers. That way I don't have to worry about finding it. This breaks down to 5 and 9, and this breaks down to 3 and 3. So this one would be 2 times 3 times 3 times 5. 39, I'm going to break that down to 3 and 13. And both of those are prime numbers, so that's my answer, 3 times 13. For -30, I'm going to break that down to 3 and 10, and then this goes to 5 and 2. So remember the list, since it's a negative number, has to start with -1 times 2 times 3 times 5. So factor each monomial completely. So this is 2 times 2, because my prime factorization is 2 times 2, times p times p. 51 would be breaking it down into 3 times 17 times b, 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 c, c. So find the GCF of the two sets of monomials. I break down the first one into 2 times 2, a, b, b, b. And the second one, the 8, breaks down to 2 times 2 times 2, a, b, b. So if I'm looking for the GCF, I've got this one, and this one, and this one, and this one, and then I've got this and this. So it breaks down to 2 times 2 times a, b, b. So it's 4a squared, b squared is my GCF. If I do this next one, 12 breaks down to, this is 2 and 6, which is 2 and 3. So 2 times 2 times 3, a, b. And 9 is 3 times 3, a, b, b, c. So the ones in common are this, an A, an A, and a B. So it's 3A, B. So my answer is 3A squared B. table below shows the number of students in a student choir. The choir teacher plans to arrange the students in equal rows. Only girls or boys will be in each row. What's the greatest number of students that can be in each row? So again, I'm finding the GCF of 48 x squared y. So 48 breaks down to 2 and 24, 2 and 12, 2 and 6, and 2 and 3. So that is 2 times 2 times 2 times 2 times 3, x, y. And 64 breaks down to 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So that one is 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6 2's. And then it was x, y, y. So our GCF, 1, 2, 3, 4 2's, 2, 2, 2, 2. And then I got 1 x and 1 y. So my answer is 16xy. True or false? All prime numbers are odd? No, because 2 is a prime number and it's even. What is it called when the GCF of two numbers is 1? Relatively prime.